Module 9 will discuss the process for performing concrete rehabilitation. There are several items to consider before programming a concrete rehabilitation activity. Need to consider if there are any widening or reconstruction projects within the same limits. The rate of deterioration of the pavement needs to also be considered. It is always a good idea to contact the maintenance office and the district materials office for any information they can provide with regards to this. Another consideration is to look at the potential issues causing the distresses on the pavement. Take note if they are related to poor drainage, changes in traffic level, types of vehicle, for example, a higher percentage of trucks, and also the geometry of the road. Before more detailed design activities take place, it is recommended to do a life cycle cost analysis to determine the long-term possibilities. FHWA Life Cycle Cost Analysis Report is a good tool to use for this. The document can be downloaded from this website provided in the slide. There are several pavement rehabilitation options for rigid pavements. One option is concrete pavement rehabilitation, CPR. This option includes slab lip replacement, installation of edge drains, diamond grinding, cleaning and resealing of joints, and routing and sealing random cracks. This option will be used when the life cycle cost of concrete pavement rehabilitation is less than the cost of other alternatives. Another method is to crack and reseat the existing concrete pavement, overlaying with an asphalt membrane interlayer AMI, place the structural course layers needed and the friction course. Rubblization with overlay is another alternative. This method cracks the existing concrete pavement with specialized equipment to reduce the nominal size of the cement concrete to less than 6 inches. Basically converts the existing slab to a high-strength granular base course and overlaying it with a structural course and then the asphalt friction course. Other alternatives are to replace the existing pavement or reconstruction. These alternatives include removing or recycling the existing pavement and replacing it with a new pavement after a pavement type selection process has taken place. A detailed analysis of life cycle cost analysis of these alternatives will determine which is the most cost-effective. Let's cover in more detail each one of these alternatives, starting with concrete pavement rehabilitation, CPR, and the rigid pavement design manual under table 3.1. It establishes the design period to be used for CPR. This is very important note. The design life is not calculated when you are preparing your design pavement report. This is just establishing the parameters for performing the rehabilitation work, and this is derived from project's historical deterioration rate and loadings. The district maintenance office can provide good information on areas that need to be looked at more closely during the preparation of the plans for the slabs to be rehabilitated, since they have the data on how often they're having to make repairs to certain areas of the pavement. This is vital information to determine the cause of the distress and could be an indication of other issues such as poor drainage, unusual deterioration due to heavy construction in the area, or a geotechnical issue. Data needed for concrete rehabilitation is to start by verifying the slab thickness. The concrete thickness can be verified by obtaining as-built plans, coordinating with your FDOT PM to request from the district materials office to obtain some coring data to verify the information. Cores are only done on slabs that are due to be replaced, as you can see in the photo. Another way to verify the pavement layer thickness would be to obtain ground penetrating radar, GPR data. The State Materials Office GPR vehicles' priority is to focus on pavement forensics investigations such as delamination, premature failures, distress, sinkhole voids, and many others. They also focus on bridge forensics investigation, which is the experimental projects and state evaluations of in-service roadways. This is an output table with slab thickness, cross slope, and rut depth, mostly being used for asphalt pavement, but it can be used for concrete. This is just to show you the tools available. Most of the time, GPR data will not be needed if there is good data from asphalt and cores that provide the thickness of the slabs. In addition to obtaining slab thickness, it is very important to get all slabs inventoried and numbered, so the existing joints are clearly shown in the plans. There are a variety of methods that can be used to obtain this information. The more traditional method used is low altitude mapping photography LAMP, obtained with a helicopter flown at 300 feet above the mean terrain as a base for photogrammetry projects requiring very high accuracy pavement mapping and elevations. This provides an accurate depiction of the joints, and it also provides general distresses captured. This ramp was surveyed using static LIDAR to capture the joints and distresses in the existing pavement. These images are from a terrestrial mobile LIDAR survey. Any of these methods are all viable alternatives on how to capture the slab joints layout. Once the survey data is received, all the slabs need to be numbered. Once that is ready, then a field review can be conducted to gather data for the type of distresses encountered for each slab. Pictures of each slab can be taken to document the slab inventory, making notes on the distresses and the type of repair method to use per standard plans 353-001. A newer method can also be used to capture distresses and capture faulting. Laser crack measurement system LCMS data, which can provide downward images or JPEGs of the slab to a resolution that can be up to 1 pixel equals 1 millimeter. Usually the default is 1 pixel equals 4 millimeters. This new technology provides an alternative method of collecting data for the distresses in the slabs, especially in a more urbanized areas where the field reviews are more difficult and traffic congestion does not allow lane closures, to perform a detailed distress analysis measurement, especially for faulting. This technology measures faulting height. This will be covered in more detail later on under the new technology under Module 11. With early coordination with your district and state materials, this data can be requested. State Materials Office currently has one vehicle to service the entire state, so currently the vehicles will be capturing data with this vehicle for mainline only, the requests from the district. If ramps or shoulder data is needed, it will need to be included under the design services for the project. Each project should be looked independently for what information is required and the constraints mentioned. This method is solely for capturing distresses on the slabs. This is used in combination with either a photogrammetry or LIDAR for the survey purposes. The images can be georeferenced into the design file so the person analyzing the slabs can compare the output in images to determine the appropriate corrective methodology for each slab. Slab replacement includes partial slab replacement, which is a portion of the slab that has disintegrated or the corners have cracked severely as shown on the right side of the slide. Full slab replacement, which is a slab from joint to joint and as shown in the center of the slide. A multiple slab replacement, which was several connecting slabs as shown in the left side of the slide. The purpose of CPR is to replace the slabs that are shattered, broken in 3 or more cells, or severely broken slabs. In this plan set shown, you see that new joints have been created because the slabs were 20 feet long. When a new slab is poured, then the joint spacing needs to follow guidance indicated in the standard plans 353-001, 1 of 2, which is minimum of 6 feet and no greater than 15 feet for the length of the new joints. Standard plans 353-001, 1 of 2, show the different type of repaired methods and how the dowels and joints are placed. It covers the minimum joint length of 6 feet in Figure 10.2, and Figure 10.3 gives guidance when slabs are greater than 15 feet and how the new joints are placed for a full slab at full depth. The longitudinal joints for slabs replacement should not be tied unless you have multiple slab replacements. In the case of Figure 10.6, only if multiple slabs, full adjacent slabs are replaced, and how the longitudinal joint tie bars are installed. Standard Plans 353-001, 2 of 2, shows the slab repaired and replacement criteria to be used when analyzing the distresses and determining the repaired method. It is always a good practice to prioritize the more severe distresses, for example, a shattered slab that requires full slab replacement, to the less severe distresses, for example, a random crack with no faulting that would only require to route, clean, and seal. This will help maintain project on budget. As mentioned before, when performing a concrete rehabilitation, it is vital to check with maintenance if there are any areas of flooding or frequent failures that will require a closer look to the drainage system. Concrete pavement should have edge drain, draincrete per standard plans 446-001, sheet 404. They show details for rehabilitation. These are just some examples of edge drain placement shown in the slide. These are some MOT considerations. Determine the work area needed for lifting the slab and activities for pouring a new slab within the night closure time frame. Lane closure analysis for closing 2 lanes or closing ramps, developing a ramp detour needs to be considered and also well detailed in the plans. Coordinate with construction and materials offices if high early strength concrete is required and include in the plans and specs. The minimum compressive strength of 1600 psi is needed prior to opening to traffic. For a full-depth concrete slab replacement, the UR should meet the CI contractor in the field to go over the plans. It is very important to go over the distress identification guidelines to avoid overruns on what is critical and what is not and can be cleaned and sealed. There will always be some discrepancies from the plans since some slabs could have deteriorated further from when the plans were finalized. So it is a good practice to discuss a prioritization method to ensure there are no extensive overruns of the quantities. The contractor will saw cut the damaged slab shown in the plans for removal. This could be 6 foot, a half a slab, or a full slab, depending on the distresses on the slabs. The minimum dimension recommended is 12 feet wide by 6 feet long. Place anchors on the existing slab to lift the slab carefully, not to damage the base. Refer to general notes on Standard Plans Index 353-001, 1 of 2 for more details. Drill holes to place the steel dowels for the new slab. If lane closure allows time to pour the new slab in time for the concrete to cure to reach the desired strength before placing traffic back onto the lanes, then proceed to do so. If the lane closure times does not allow time to pour the slab at this point, place the existing slab back in place until the next day when the pavement operation can be completed. Contractor always should keep spare emergency slabs to place in case the slab being removed breaks into pieces. Before pouring a new slab, ensure the base has not been disturbed by the removal of the broken slab. Concrete is poured, then vibrated and rolled for a smooth surface. As mentioned before, the slab needs to achieve at least a 1600 psi before placing traffic back onto the new poured slab. Once the slab replacement activities are finalized, diamond grinding can be done on all the slabs for the project limits. Diamond grinding also helps remove surface irregularities such as faulting when it's less than ½ inch, improves the ride and results in a quieter road. This operation is done before you clean and seal all the joints. More information can be found in Standard Specifications 352. Once the diamond grinding is finished, there will be a noticeable improvement to smoothness, but the ridges also improve skid resistance and safety. For specs, when tested with a straight edge, the finished pavement profile should have a uniform surface with no deviations greater than ½ inch in a 10-foot length. Once diamond grinding is finished, then the slabs can be cleaned and resealed. Random cracks with little or no faulting at either side can be routed, cleaned, and sealed. For example, longitudinal cracks, as you can see in this picture. There are some other department recommended rehabilitation alternatives. They are crack, reseat, and overlay, CRO, rubblization, recycling, and patching. Crack, reseat, and overlay, CRO, consists of cracking the concrete pavement into pieces 1 to 3 feet in size and firmly reseating the pieces into the subgrade. Overlaying with an asphalt membrane interlayer AMI prior to overlaying with asphalt structural course and friction course. The pieces of concrete are broken into a panel breaking machine that drops a heavy weight, approximately 12,000 pounds guillotine type hammer for cracking the pavement to break the concrete. Then a compactor rubber tired roller 35 to 50 ton presses down the concrete onto the existing base to ensure the concrete is seated well into the ground. An AMI layer is used to prevent reflective cracking and provide a waterproofing layer. This method is only used on jointed plain concrete pavement, JPCP types of pavement. The structural coefficient table here provides a range depending on the condition of the pavement from good to poor to determine the base strength. Design details need to be provided for areas where there is a transition into a bridge approach slab. An appropriate thickness transition length should be provided for high-speed facilities. Another area where design details would need to be provided would be an area of a bridge underpass. If the pavement still has a large amount of water in the pavement system, using edge drains may provide an outlet for the water before the cracking and reseating operation is performed. The rubblization technique can be used on all types of concrete pavement. This rubblization was performed on a 22-mile stretch of I-10, State Road 8 in Jackson County. The concrete slab was destroyed, as you see in this picture, by pulverizing the slab into 1 to 3 inch chunks at the top and 3 to 6 inch chunks towards the bottom. This process reduces the slab to high-strength granular base. This process helps also prevent reflective cracking. The typical section shows the rubblized existing concrete left as a base, and on top the asphalt layers can be placed. In this case, they included a Type SP structural course and FC5 friction course. This project was constructed late 1998 to 2001, and the work also entailed installing edge drains. More pictures can be found in the pavement management site link as provided on the top right part of the slide. Rubblization has performed better than cracking and seeding on I-10 specifically. We have not used rubblization anywhere else in Florida. So rubblization may not necessarily be a good option for urban areas due to the potential of disturbing utilities. However, since it is performed well on I-10, it may still be an option for more rural areas. This is a task team report performed on some of these projects, and the report did indicate that some of the projects had rubblization performing much better than crack and seeding, and that can be found on page 23 of the report on the link provided on the bottom left. Reflective crack membrane used for asphalt overlay. These pictures show placing a reflective crack membrane or stress relief inner layer over the existing rigid pavement joints. This was done before placing an asphalt pavement on top of the existing rigid pavement joints. This is a project US 19 north of Gandy Boulevard in Pinellas County. This was done to help reduce the reflective cracking onto the new asphalt. The material being used is a high-density asphalt mastic material called PavePrep, and this was used as a mitigation strategy, but not necessarily for a long-term solution. Recycling concrete aggregate, RCA, are covered under specifications 901, 902, and 911, and those cover all the requirements and use. Need to highlight that RCA cannot be used on interstate, and the use is limited to non-limited access paved shoulders, shared use path, or non-traffic bearing applications. Section 285 for optional base covers the use. In addition to the mentioned specifications, for FDOT, the source shall have a DEP permit per section 62-701.730, or be qualified as a clean debris source under DEP's rules to assure that there are no toxic contaminants in the materials such as asbestos or lead. Patching is a method used for isolated or random spalls and or corner cracks. A fiber reinforced polymer patching material may be used. That is developmental specification 351, and the website is provided in the slide. There's no current projects that are using this developmental spec. However, the maintenance office has used it in the past. Other alternatives used in other states: load transfer restoration, LTR. This method drills through the concrete slab to add new bars for load transfer. The pictures you see here, it is a track milling machine with a roto mill head for dry milling 3 slots into the concrete slab for placing the epoxy coated bars in the areas of the wheel path. The area is cleaned thoroughly before adding a quickset mortar. Then epoxy coated bars are placed, and then additional rapid setting mortar is placed on top, as you can see in the second picture. The restoration of load transfer has been tried in undoweled pavements unsuccessfully in Florida. Until further research shows successful performance for Florida, this method is not recommended at this time. The pictures shown here are from an interstate project with Indiana DOT for a 10-inch thick reinforced slab at 30-foot spacing. This method of inserting dowel bars into the existing pavement is to address faulting issues in older jointed concrete pavements. This concludes Module 9, Concrete Rehabilitation. You're now ready to proceed to Module 10, Concrete Overlays.